Hi everyone, welcome to an introduction to AI and machine learning session. It is an open session for the course on AI and deep learning by IIT Roorkee. Alright, so we are going to start in 6 more minutes. Please feel free to ask questions using the chat, YouTube chat. Alright, so this is an open session by myself, Sandeep Giri. This is an introduction to AI and machine learning. We will talk about what is AI, what is machine learning, and so on. Okay, so we have 6 minutes to go, and we are about to start in 5 more minutes. So stay tuned. Stay tuned. Use the live chat. There are going to be many viewers on this particular session. It's an open session for everyone. The next session that is going to be on 6th June, the next session that's going to be on 6th June will be delivered by the instructors mentioned below, like Sandeep Giri, Professor Durga Tushniwal, Professor Gaurav Dikshit, and Praveen and Abhinav. They will be delivering the next session, which is on 6th June. The content and subject will be the similar, what we are going to discuss today. Today's session is open to all. The next session will only be open to the enrolled candidates. In the next session, you will be able to ask questions, and in today's session, you will be only able to type questions in the chat. The next session will be delivered using Zoom. Today's session is being delivered on YouTube Live because it is open for all. All right. So feel free to ask questions. Please do not spam the chat, because my team and myself, we are online on the chat. We would be monitoring it, and we might block you from the chat. All right, so be polite and nice to the other users on the chat, and feel free to ask questions on the chat. Utilize this opportunity to get your doubts cleared, and I'll try my best to answer your questions. So we have 4 more minutes to go. So this session is open to all, while a similar session which is going to be conducted on 6th June, the topics and the subjects are going to be same on 6th June, but today's session will be delivered by myself, while the next session will be delivered by all 5 of us. Okay, next session only the enrolled candidates will be allowed, and this session it's open to all. This session is being delivered on YouTube Live, while the next session will be delivered on the Zoom. Okay, since it is an open session and since there are many candidates who have enrolled here, therefore it was not feasible to conduct this session on Zoom. All right, so these presenters we have already decided based on their subject of expertise. Some chapters during the course will be taken up by myself, some will by Professor Durga, and some by Professor Gaurav, and some by Praveen and Abhinav. So based on their area of expertise, we have divided the chapters, and that's how it will be conducted during the actual class. All right, so we have 2 more minutes to go, and then we will start the actual session. Feel free to ask questions during the session. A question from Abdul is, what's the trade-off between bias and variance? Probably I would save this question to a second session that we are going to talk about end-to-end machine learning. Today we are going to touch upon the basics of machine learning, we are going to talk about machine learning types and so on. All right, so wonderful, wonderful. We are about to start in a minute. Okay, so we are about to start in a minute. Okay. Let me turn off my phone by then. Perfect, perfect. If you have any question at any point of time, feel free to let me know. Okay. I've turned off my phone. Let's get started. Welcome to the session on AI and machine learning. Today is the introductory session. This is usually the first session of our course, and it's going to be for 3 hours. First, we are going to discuss briefly about IIT Roorkee, CloudX Lab, about the course, and we will also briefly introduce the instructors for the course, and I'll introduce myself as well. And then we are going to talk about what exactly is machine learning, what is the difference between machine learning approach and general approach. And in the meantime, we'll also discuss a couple of concepts like big data and IoT. So during the machine learning itself, how the dots connect, we are going to talk there. Then we are going to talk about what exactly is AI, and then we'll take Q&As, and afterwards we'll discuss like machine learning types and neural network. This break could be before or after, so stay tuned. This is not necessarily the break is going to be here. Probably the break might happen here. All right. So what we'll do is we will at around 9:15 we will start taking questions, and or around 9 o'clock we'll start taking questions, and then we'll take a break at 9:30, and then we'll continue the remaining topics. This is going to be a 3 hours course, 3 hour session, which will basically touch upon all the ideas in machine learning and AI, and also some ideas in big data. All right. This is a free and open session by myself, Sandeep Giri. I'm from CloudX Lab. The first session for the enrolled candidates is on 6th June, which will be delivered by all of the 5 instructors that are mentioned below. While today's session is open to all, the next session, which is on 6th June, though the subject is going to be similar, but it will be delivered by those 5 instructors. Today's session will be delivered by only myself. And in the next session, we will have Zoom instead of YouTube Live. And in the next session, only enrolled candidates will be joining. Except for myself, everybody is on mute. And please use the YouTube comments to ask questions. Ask your questions briefly, but do not use the chat language. All right? My team and myself would be looking at your questions all the time and would try to answer your questions in the chat. And I'll also take the questions before the break. The recordings of this session along with these slides will be shared with you after the session has finished. So this is going to be the sequence of things. All right. After the break, we're going to learn the machine learning, neural networks, and everything. All right. And briefly, I'll also cover the computer vision in like 5 minutes, so that you get a fair amount of idea what are the various concepts or the ideas inside the machine learning and AI. All right. You will get to know things like supervised learning, reinforcement learning, unsupervised learning, model-based learning, and so on. Everything in the machine learning types. All right. Great. Wonderful to have such a great audience. People from all across the globe have joined this session, and we are going to Just go ahead next. So since it's a course, this is a open session for the course by IIT Roorkee. So I'll just give you a brief about IIT Roorkee. IIT Roorkee is second oldest technical institution in Asia. It was formerly University of Roorkee, and before that it was Thomson College of Civil Engineering. It is located in Roorkee, that's why the name Roorkee, and which is in Uttarakhand, which is in India. It was established in 1847, which is way, way old. So it started as a civil engineering workshop and then evolved into civil engineering college, and that's my alma mater as well. So you can take a look at what exactly is IIT Roorkee. And myself, I am the presenter or the instructor for today's course, today's session, and I'm Sandeep Giri. I graduated from IIT Roorkee long back, 2002, and then I've worked largely on the large-scale computing. Most of my career has been into large-scale computing at D. Shaw, Amazon, and InMobi. And I'm at heart a software engineer, and I enjoy explaining technologies. That's why I started my career as I started the CloudX Lab along with my team. So wonderful. So this is about me, and I'll give you a brief overview about the course, how it's going to be, and so on. And this is the introductory session, the first session of the course. And this is an open session. This will be redone on next Saturday, coming Saturday, by the other the instructors along with me. Now, about the course, it's a certificate course on AI and deep learning by IIT Roorkee. And the agenda is to learn Python, NumPy, Pandas, TensorFlow, Keras, and basically all the tools along with the concepts and the theory and ideas, the mathematics also behind the deep learning and machine learning. So you can take a look at the course at this URL. I'll give you a brief about the course. So the course assumes that you have basics of Linux by clear to yourself. For that, we have also provided a self-paced course. This course on Linux is well known and people really use it, and it's for free again. Then we have a course on Python for machine learning that you can enroll at CloudX Lab. These three things come free in this course as self-paced, so you have to finish there. Now, the introduction to machine learning and deep learning is something that we're going to discuss today. Afterwards, towards the next session, what we're going to do is we're going to do, from the 7th of June onwards, what we're going to do is we're going to do the end-to-end machine learning project. And by the way of doing that end-to-end machine learning project, we will learn data processing, regression, and so on. Afterwards, we'll do an end-to-end machine learning project using classification, specifically on the image recognition dataset, and understand all the vocabulary and all the concepts and ideas in the classification. Afterwards, we'll cover the machine learning algorithms, understand how a decision tree works or random forest works, or briefly SVM works, and then we will also talk about the unsupervised and so on. Afterwards, we will start from the 8th chapter onwards. We're going to start the deep neural networks. So first we'll touch upon the how to create a neural network in the session number 8, and then we will learn the theory and maths around how to train the deep neural network. That's the chapter number 9. Chapter number 10 revolves around creating custom models and training with TensorFlow. This is TensorFlow 1 in chapter number 10. That's the only chapter with TensorFlow 1. Remaining chapters are around TensorFlow 2. Then we will learn how to load and pre-process data with TensorFlow. And then we will learn to do the computer vision along with the deep ideas about CNN and so on. There are many recent researches that have come into play. So those will be covered in chapter number 12. In chapter number 13, we will be processing sequences using RNNs and CNNs. It's a combination of, it's basically starting off the recurrent neural network, and it builds upon the ideas that you learn in the previous chapter. Then 14th chapter is around how do you process the language using the RNNs, the recurrent neural networks. In chapter number 15, we will learn what is generative learning using autoencoders and GANs, right? What is generative? It's called GAN, generative adversarial neural network. What happens over there is that most of the things that we learn in machine learning is about predicting a number, predicting a class, right? But in generative, we learn about how would you create music? How would you create prose or poetry using the computer? Along with how would you create or paint a face, a new face that you have not seen before? So all of that we will cover in chapter number 15. Also, we'll cover something very interesting called deep dream in chapter number 15. Chapter 16 revolves around reinforcement learning. In this, we will learn about how do you train a bot to play in an environment. Given an environment and the rules of that environment, how would a bot learn by itself? That is covered in chapter number 16. So that was a brief about the index. We're going to move ahead now. So this course basically the basic foundation things we learn, the data processing we learn in NumPy and Pandas. Then basic machine learning we learn using the machine learning library called scikit-learn. And then Python is kind of the main language that we are using. So Python, NumPy, Pandas, scikit-learn, then TensorFlow and Keras. TensorFlow and Keras are specific to deep neural network. So we're going to use these tools and libraries for this class. All right, this class is in this course, the one that I just talked about. In this course, we'll cover all of these along with the deep ideas about the machine learning and deep learning. Also, please keep in mind that even if you are interested to go with, say, other libraries, the theory and concepts around deep learning and machine learning remain exactly same. All right. So this is a snapshot of the certificate. The certificate will be distributed online, and in case the lockdown is over, which I don't think will be over, in case the lockdown is over, we will have the convocation at any of the physical locations. All right. But even if there is a physical convocation, the online the soft copy of the certificate will be sent to you along with the URL. Now, moving ahead, in this course is taught by Professor Durga Toshniwal along with other instructors. Let me introduce Professor Durga Toshniwal. She's a professor at Department of Computer Science and Engineering and head of the Center for Transport Systems and at IIT Roorkee. She has 19 years of industry research and teaching experience in AI and machine learning and data mining and big data. Also, she has experience in social media and data analytics, natural language processing, and intelligent transportation. She has guided 12 MTech dissertations and guided 80 plus. So she has guided 12 MTechs and guided 80 plus dissertations. Then we have Gaurav Dikshit, who is an assistant professor at IIT Roorkee. He has been in a career been from consulting as well as advisory background. So he has IT strategy, AI, ML, and data science e-commerce background. So he has worked with HP and he has done his PhD from IIM Indore, and 8.5 plus years of experience in diverse portfolios. Given the profiles of Professor Durga and Gaurav, you can see that you will definitely be benefited by their experience and their way of education. And I've already introduced myself, and here is Praveen. Praveen is a co-founder at Yathis who does the deep learning on the edge devices. So his specialty is computer vision and edge. He is a graduate of IIT Bombay in 2001. Then we have Abhinav. Abhinav is my co-founder at CloudX Lab, and he has a very good experience with scaling as well as the AI and machine learning understanding in general. And he's also visiting faculty at other institutions like SCMHRD, as well as IFIM and few more. Along with that, he has a very good experience in gaming engineering and so on. All right, so yes, I mean, the introduction might be taking a bit of time, but it's important to know who is going to be teaching you so that you are in safe hands. You feel safe in the course that you are going to learn from the experts. Now, all right, briefly about CloudX Lab. At CloudX Lab, our entire focus is to make learning fun and for life. So there will be in usual one, we have live instructor-led trainings. The self-paced courses have videos. There are quizzes, there are hands-on assessment, and there are going to be projects and case studies based on the real-life use cases. Now, in this, if you see that in the case of auto hands-on assessment, something that we have done very differently from everybody is this, that when users are learning in the self-paced course or in the exercises in the live instructor training, in either case, everybody would get quick feedback by the system. And this way would help you staying focused to learn to solve problems, and also will make you more and more hands-on person, and instead of more theory. So here, this is a online, we have, along with auto hands-on assessment, we have provided the entire environment on the cloud so that you can do anything that you want from office, from home, and anywhere. So you don't have to install anything on your machines and so on. So the online cloud-based lab gives you multiple advantages. One, you get real-world experience. When you're working in an organization, the chances are that you won't be using your own desktop. You might be using a cloud-based system or your organization's network. And therefore, this lab is really useful. The other advantage of this lab is that this lab has the intercomponent learnings. Like, for example, you want to learn how to do machine learning or deep learning using Hadoop or Spark or other tools. Those are all supported. Now, there is a seamless experience that you don't need to download or anything, and there are centralized data sets. So you don't have to rummage around for the data set. Usually what happens in the class is that you end up giving the USBs to the people, and there's always this question, where is my data? In our case, since the data is same for everyone, the location is same for everyone, so the scripts don't need to be edited or people don't have to rummage around for the data. You can access it from anywhere. Okay. The other advantage is that you get a feel that you will see other users who are also studying, so you will see that how you are performing with respect to your XP points. XP points are basically representing XP points are representing what is it that how well you are performing. So here you can see that as you progress through your learning, your profile keeps getting updated, and this improves your visibility as well as this improves your social quotient. Now then there is a forum on which there is a lot of active discussion. You participate in the discussion, or you ask a question or answer. This would help you develop in general. Now, we have a job portal, so we are having multiple users or multiple people apply, post the jobs, and we recommend our candidates. Now, let's get to the substance for today. So 18 minutes, we have finished the introductions, and we have also explained the courses. Now, let's get started with the main substance. So today, we are going to talk about machine learning from now onwards. Perfect. Now, so what exactly is machine learning? What do we understand by machine learning? So here is a big boring definition. It's by Arthur Samuel, one of the researchers who laid the foundation for machine learning. So fields of study that gives computers the ability to learn without being explicitly programmed. It's a field of computer science which which deals with giving the ability to the computers so that the computers can learn without being explicitly programmed, so that the computers can look at the data by themselves and learn by themselves, and you don't need to code them. Now, this definition might sound good and you might have understood it, but let's take it with a real use case. Again, I'm going to take an example of Mario. When you play Mario, what happens, right? So what you do is there is an environment and you press keys, observe the screen, and then you try to gain the score, right? The question is, can a computer do exactly the same thing? The way you learned playing Mario, I'm sure most of you have learned, most of you know how to play Mario, right? Can a computer learn to play Mario just like the way you did? Yes? All right. And if so, do you think it'll take a long time to win the princess? Let's take a look. Can the computer learn to play Mario just like you did? All right. So here is a demonstration of the program learns to play Mario, observes the game and presses the keys, okay, and maximizes the score. Let's take a look. I think this demo will make sense to you. All right, here we go. All right, this is the day 0 and the program is playing Mario. It's pressing random keys and going nowhere. You can see that for whatever reason, it's just jumping around. So, but after a few more tries, it has learned what to do, right? It's more like toddler. It has figured out that you can move this way, right? It's able to look forward and figure out what's going on. Do you think he'll cross it? It was badly stuck. So after a few more weeks of learning, he's almost there. He's, I think, better than me if you look at it. All right, it's building the intuition. Do you see that? It's building that intuition, right? So few more weeks of learning without knowing physics, without knowing colors or anything. It figured out by looking at the data, looking at the screen, by pressing random keys, it has figured out how to play the game. Do you think he'll cross it? Yes. All right. So as you can see that it is having no problems at all. It's having no problems at all. Now, few more weeks and it would be like more than an expert. All right. Now you will see an amazing thing here. It's going to exploit a bug in the game what was that? It exploited a game. The moment the Goomba was jumping on it, it started moving downwards and it got the point. So it figured out there's a bug in Mario game that when the Goomba is jumping on you, you start moving downwards slowly. And that's when you get the points. Now here, you see this? This is the another bug that it is exploiting. I have no clue how did it do that. Now, the most important part is that it is starting to show the signs of intent. Since it was not able to learn or win, it paused the game. It kept on pausing the game because it could not learn. Just like in childhood when our cousins could not win against us, they will spoil the game and run away. And that I did very often for the chess. All right, so great. Let me just check if there are messages for me. All right, so here we go. So this was, let me make it a full screen. Okay, for whatever reason, it's not going full screen. All right, so this is what we did, and so what we did just now, what we showed you was that the program or the computer or the algorithm learned to play Mario and other games without any programming. We did not teach it what is falling, what is rising, what is moving. We did not teach it. We just told it, do whatever you can just to win the score. Maximize your score, whatever is the possibility. Okay, so it started playing and figuring out that jumping up and down gives advantage, and if the screen is like this, then go to here and so on. So it learned from few things. One, the current screen and the key that was pressed and the score that was displayed. So those three things: the screen, the keys that were pressed, and the score, which reflected whether it is winning or losing. Now, now this is something which is called machine learning. Now, a quick question to you is that to make this program learn any other game such as Pac-Man, we will have to, number one, write new rules as per the game, or just hook it to the new game and let it play for a while. Which one do you think is right? First, writing new rules or coding for each program, or just hook it to the new game and let it play for a while. Which one do you think is more true? One or two? Yes? Yes, that's right. The answer is the second one. All right, so I just waited for your questions and perfect. Now, the way program played Mario, can you imagine doing the same thing for life? Gather data and automatically solve the problems. Gather data and automatically solve the problems. Okay, and that's about machine learning. That's about machine learning, gathering data and automatically solving problems. Now, now, other important idea that I want to drive to is that machine learning is going to be in every industry, because every industry is trying to predict, whether it's manufacturing industry, which is trying to predict that what kind of products to manufacture, what kind of processes optimizations need to be done, and what kind of pricing they should come up with in order to sell their product, and many more. So manufacturing industry is trying to predict many things. Similarly, agriculture industry is trying to predict what? Which crops to grow, what would be the price of those crops, and what should be the process so that we can maximize the produce. So agriculture industry is trying to predict something, right? Similarly, the healthcare industry is trying to predict something. It's trying to predict what kind of disease a patient has based on the syndrome, what drugs are more effective for a particular disease, and and how can a pandemic be stopped or can be slowed down, which operating procedure is more effective. But the common theme in everything is predict. So healthcare industry is trying to predict something, correct? While in case of stock market, the prediction is very, very obvious, right? The various kinds of companies keep on trying to predict the stock prices of various other companies and so on, right? So every industry is trying to predict something. Every company is trying to predict something. And prediction is something that's done by machine learning based on the data or based on the past experience. And this is exactly the point. So, since every company, every industry is trying to predict, the machine learning is going to be used in everywhere. It's up to you to figure out how you can gather data. It's up to you to figure out how would you clean up the data, process the data, and then what would you like to predict. So when you understand an industry, you will try to understand like what kind of data we have and what kind of predictions do we need. And this is exactly where the role comes, right? So as of today, almost every company in the world has moved to deep learning or machine learning. If you take a look at the companies like Google or Microsoft or Facebook, earlier the teams were teams who are doing video processing, teams who are doing audio processing, teams who are doing the analytics. All of these teams were separate. Now they have more to do with each other than before, right? And this is a new era whereby the algorithms which were written by people earlier will be written by the computers now. Like, for example, self-driving cars on the road. Earlier, people have been trying to make self-driving car for very, very long time. But earlier, the approach was that people would write those rules. If you see this, then do this. If you see this, then do that. Right? Those kind of rules were written by people. But now, those rules are created based on the data by the computer. Although self-driving cars on the road are both combination of human-coded rules as well as machine-inferred rules, both. Now, Netflix movie recommendation is another example which actually set off the machine learning championship, the thing that you call Kaggle today, where all kinds of machine learning researchers are competing. That place is basically that Kaggle came from the competition that Netflix started. It was about generating recommendations. Now, generating recommendations, if you look at closely, is essentially learning from the data and predicting who will like what. People who are having similar watching habits, if you can bucket them together and predict what they will like it, that is the recommendation. I have built the recommendation at InMobi long back using 200 terabyte data. So I realized that the recommendation engine is a classic example whereby machine learning and humongous data both intercept. Amazon product recommendation. Since I come from Amazon background, the Amazon detail page, this is something very close to me, very close to my heart, because this Amazon product recommendation improved Amazon sales by initially by more than 40%, right? I'm not sure about current statistics, but in the beginning, their emails, their website, the recommendation that was shown on the website and the email were way more effective than the usual marketing, because this was something really, really game changer. Similarly, the Google also does a lot of machine learning in ranking the results and recommending the results based on the individual's behavior, individual search history, and so on. And the speech recognition, earlier it was a coded one, people coded it and tried to do it by hand, but that did not work out well. But today, the rules that have been coded by the computers, or you can say using machine learning, most of the models that are made are performing way better than the classic ones whereby human coded the rules. So basically, to solve most of the machine learning problems, you need two things: data and algorithm, or you can say data and intelligence, correct? And these two things, further, I'm going to take one at a time. Let's take the data part. For data, we need to gather data, right? In case of Mario example that I took, the data was there. The data was there because it kept on playing by itself, kept on generating the data. But in case of normal life, gathering data is way more hard, right? So the data part has like three parts, like one is collect, clean, and then do the basic processing of the data. For collecting the data, we have today the IoT, right? You have, as of today, lots of input sensors and data gathering technologies have come into place. For example, the phone that you carry has way more sensors than any laptop or any other machines, right? So phones, or you can say the IoT devices, like the sensors that you can put at various places in your farm or in a factory and anywhere. So gathering data has become easier than before. On one hand, we have the phones and devices and sensors, the hardware. The hardware has become cheaper, faster, and smaller. The three things. Those who are coming from the electronics background, they can connect with these three words that every year they have been trying to make a product cheaper, faster, and smaller, right? So today, on one hand, the hardware, the phone, the devices have become cheaper, faster, and smaller. On the other hand, the network connectivity has improved. The network connectivity, as in the Wi-Fi, 4G, and NFC, Bluetooth, GPS, infrared, and so on. There are so many ways to connect the devices and transmit the data. While on one hand, devices are more like generating the data, and connectivity is more like transmitting the data, or you can say copying the data, or you can say duplicate the data. For example, right now I'm speaking here, and by the end of 3 hours, the session will be uploaded, the stream will be consuming 3 GB, right? And to all of you, since there are 160 users, the total transmission will be 160 GB. So you can see that the on one hand, we have the data generation, on other hand is the transmission. And when we need to process this data, this humongous data that we are generating, why do we need to process the data? Because we can do predictions from this. And when you need to do process, like you need to separate the noise from the signal using basic techniques, or you want to just do the basic filtering, all of that would require many computers. That's called the distributed computing and the big data engineering. So when you have data, you need to store it, upload it, and process it. Generate, transmit, and process it. And for processing the big data, you need many computers. That is handled by distributed computing, or you can say big data computing or big data engineering. For that, people generally take up the other courses like the big data engineering we have, and in these, where you have to handle terabytes or petabytes of data, you generally use Hadoop, Spark, or any NoSQL databases in order to store and process that amount of data. So in order to achieve the prediction efficiently, you need data and you need intelligence. For data, we need to have the gathering of the data, transmission and cleaning of the data, right? And for the intelligence, we need machine learning, right? We need machine learning, and once the data is clean, it has been processed well, and then we can feed it to the ML algorithms, and they can generate the rules by itself. All right. So I want to take a very simple example of traditional versus the machine learning approach. Okay, we're going to take an example of the difference between traditional and machine learning approach. How would you write a spam filter? What is a spam filter? You must have seen your Gmail, you will have inbox. In that, there'll be a spam box also. So it detects which email is a spam, which email is a regular email, or we call it ham. So let's say we have to build this solution to do the spam filter, right? The traditional way was we studied the problem, we as in engineers, the humans, the people, they study the problem and they come up with the rules, right? They'll come up with the rules like if the email subject or body is having a keyword like credit card, free or amazing, it's a spam. Let's say this is the rule that those scientists or engineers they came up with. Soon enough, they might also come up with the other kind of rules that if the sender's email address is abc at xyz or webmasters at mysite.com, it is likely a spam. Okay, when it crosses these rules, all of these rules, that means it's not a spam, right? Now, the engineers would write the rules. The engineers would write the rules and they feed it, right? This is how it will look like. You have lots of rules, incoming mails are there, and then you are putting it into one box or another. Those who are familiar with this approach, they can recollect that there used to be this rule engine, business intelligence, business BRM, business rule management systems. So it's a very common technique. For example, if you think about how let's say your telecom network work, they also keep on creating these rules that if the person has called for this much time, then do this and so on, right? So this is where this is how the traditional approach looks like. You have incoming emails, they're passing through the rules written by the people as in engineers or scientists or data analysts, and then those rules are being deployed in the production, and the system is basically executing those rules and putting emails into spam or inbox. Now, you evaluate this model and push it to the production if it is working well. So we studied the problem by ourselves. This is a traditional approach. We studied the problem, then we wrote the rules and we evaluated those rules. In case those are working well, then we push it to production, we launch them. If they're working well, we evaluate. How do we evaluate? We break the data into test and training and we compare whether our rules are working well on unseen data, and that's how we do that. Now, once we launch it using that blind fold testing or whatever, and then if it's working well on unseen data, we basically push it. Now, if it's not, then we go back to studying it, right? Now, do you see any problems with this traditional approach where people were writing these rules? Do you see? Oh, okay. So, so far what we have covered is we have covered about the course, and then we have talked about the basic machine learning, and we have also talked about where does the big data engineering comes into play, and we have also talked about various use cases. Now, just now what we are discussing is we are trying to compare how a product is built or how a software is designed today versus 20 years back or 10 years back, right? So traditional approach is that people write the rule and those rules are executed in production and that's it, right? Now, there are some problems associated with the traditional approach. The first one is just too many rules. We end up with too many rules. It's just so difficult to manage or maintain these rules. Second, if spammers know about the word amazing, they will come up with a keyword like fantastic, right? So the spammers could come up with new keywords. When the moment they realize that, okay, these words are blacklisted, let's do something else. Let's use some other words, just like virus versus antivirus, okay? And And therefore, this manual rule creation is not efficient. It's not efficient because it requires a lot of hard work, and people, it's not really foolproof, right? Now, let's take a look at the spam filter using a machine learning approach, right? We, the engineers or the scientists or the data analyst, we study a problem, and then we train the machine learning algorithms on the given data. We give the data, we format the data, we feed it to the algorithms. Algorithms come up with these rules, or we call that model, and then we evaluate that model. If it's working well on unseen data, the data on which it was not trained, if it is working well, then we launch it. Otherwise, we go back to studying the problem with it, right? Now, this approach is something that works pretty well. And this is exactly the machine learning approach. As opposed to the previous workflow, this is exactly the approach this is exactly the approach that is part of the machine learning flow. Let's move ahead and try to understand what exactly is AI. So AI is the intelligence exhibited by machines. AI is the intelligence exhibited by the machines. Okay? It is not the tool, it is not the suite of components, it is the objective that AI is essentially an adjective saying this machine is intelligent, so we call it AI, artificially intelligent, right? So the intelligence exhibited by machine is known as AI. All right, usually we see this that, okay, can AI solve this? No, artificially intelligent machines can solve it, but AI is just an adjective, okay? So AI is the theory and development of computer systems to perform tasks requiring human intelligence, such as visual perception, speech recognition, decision making, translation between languages. So AI is essentially the theory and development of the computer systems to perform tasks that require human intelligence. So the theory and development of computer systems to perform artificial intelligence, make the computers artificially intelligent and make the computers as artificially intelligent, we call that AI, artificial intelligence. Okay? Now, so essentially, we are trying to create a machine which can mimic an animal or which can mimic a human. Human is more relatable here. So this fad or this obsession of people to create something that can behave like a human is not new. It's not new. It has been there for very long. In mythology, there was a mechanical man in the book called Talos. Now, similarly, in Mary Shelley's novel called Frankenstein, there is a monster, Frankenstein monster. The Mary Shelley has described. Similarly, there are many other fictional books, mythologies, where we have been we've talked about creating a mechanical man, right? So this idea of creating a mechanical man or creating a man uh, by by mechanical means or physical means is not new. It has been very old. The term AI or artificial intelligence was coined by John McCarthy along with Marvin Minsky, Claude Shannon, and Nathaniel Rochester. And essentially what they did was, in one of the workshops, essentially what they did was they laid down the foundation of sub-objectives of AI. They said that in case a being or a machine shows these 5 characteristics: perception, reasoning, navigation, natural language processing, and representing knowledge. If a being is displaying these 5 characteristics, we call that being as intelligent. Okay? So, representing knowledge is like understanding and classifying terms or things in the world. For example, what's a computer, what's a thought, what's a tool. Earlier, people thought that the representing knowledge was something to do with computer languages, right? So they created Lisp. Lisp was a programming language that came out of MIT in order to design an AI so that machines can represent knowledge. But soon enough, people realized that it's not about the language. It's about what those words represent in this world, right? Imagine like Mario talking to another characters and behaving with them. So, so those words, that invention of word is something that we need to look at. And today, most of the machines can do pretty good work. We will cover this part, understanding the natural language processing using RNNs, whereby we will show you how well computer can understand a language. Like for example, the computer today can understand that king minus man plus woman is queen. The computer can do that. I'll give you a demo sometime. Similarly, the computer today understands that based on the data, based on looking at the newspapers, by reading newspapers, computer today has learned that the frog and the toad are similar things. And similarly, it has figured out a lot more things about the world by reading newspaper and other public data available. Like for example, it understands that rat and the mouse are the same thing based on looking at the context. So today we are very close to representing knowledge. The second sub-objective way for AI is reasoning. Can the computer play the game like chess, Mario, Go, or prove geometry algorithms? This is the second sub-objective. So if a machine shows these sub-objectives and has the capability to achieve these sub-objectives, then we call that AI, that the machine is artificial intelligence. And machine is able to do this because the computer won against the world champion of a game called Go. AI can navigate. Okay, so the third sub-objective of AI was whether something can navigate by itself. Can it locate the destination? Can it pick the correct path, shortest path? Can it avoid the obstacles? Can it move? That's the next objective. The other objective was, can it do the natural language processing? Can it speak a language? Can it understand a language? Can it make sense out of the sentence using the knowledge? The next sub-objective was the perception. Can it perceive things like you, like people, right? And the perception today is built using many things, using camera, infrared, using other mechanics like NFC. So the perception is something really important. And if something is matching these sub-objectives, it was hypothesized that the generalized intelligence will arrive by itself. With the previous building block that we just discussed on AI, right? It was said that that the general intelligence will emerge, like emotional intelligence, creativity, reasoning, and intuition, right? It was, it is clear that in case something can predict something, it would be creative. All right. So AI is based on those sub-objectives. So now, how to achieve AI? How to achieve those 5 sub-objectives? It can be achieved by 2 things, hardware and software. Some of the hardwares are used for AI. Like for example, the sensors, the ability to move, motors, and so on. Those are the hardwares that you would need. And on the other hand, we have software. Software is of 2 forms. One, coded by people, rules created by the people. And second one is the rules inferred based on the data by the machines. We call that machine learning. Now, machine learning has a subcategory under it. It's called deep learning. Deep learning is the deep learning is that machine learning which is designed around the neural network, around the design of animal brain. Of course, it's not exactly like animal brain, but it is, idea is very similar. So deep learning are those algorithms inside machine learning that are designed around the human brain or animal brain. All right. So that's what we call the machine learning. So this is how we achieve AI by the way of hardware and software. In software, we have 2 kinds of software whereby rules created by people, right? The under machine learning, there are some of the algorithms, there are many different kind of algorithms that are there in machine learning, which learn from the data. Some part of it is designed on the animal brain, and that we call deep learning. Okay, so though the term deep learning is loosely used in many contexts, but deep learning is essentially that revolution that started when people realized that they can create artificial neural network and train them. All right. One more thing I forgot, what was the IoT? IoT is Internet of Things. Internet of Things is the things that are connected to the internet, sensors that are connected to the internet, that transmit the data, right? That's called IoT. IoT has more to do with the hardware, electronics, sensors, and transmission of the data. And IoT devices are generally work as a feeder to the big data systems and to the machine learning systems. Wonderful set of questions. So moving ahead, feel free to ask questions using the live chat. Perfect. Perfect. So the next question that we have is, how do you classify the machine learning algorithms? Right? So machine learning is essentially learning or inferring the rules from the data. There are many kinds of machine learning. I'll talk about those different kinds. You can categorize machine learning based on 3 ways. There are 3 ways in which you can categorize machine learning. The first way is whether something requires human supervision or not. Based on that, we have supervised machine learning, okay, unsupervised machine learning, and reinforcement. So machine learning is of 3 types if we categorize based on whether it requires human supervision or not, right? So we have, one is called supervised, other is called unsupervised, and reinforcement. Keep in mind that reinforcement is a type of supervised. I'll describe it soon. So Machine learning, if it is categorized based on whether it requires human supervision or not, is basically of three types: supervised, unsupervised, and reinforcement. Now, the supervised machine learning is a machine learning in which it's a branch of machine learning, or you can say that set of algorithms which are trained with human supervision. So the problems in which we train the machines tell that this is right, this is wrong, this is spam, this is not a spam. Those kind of problems, we basically, those kind of problems in which we tell the machine explicitly that this is A, this is B, this is C, this is D, and so on, right? That is called the supervised machine learning. Supervised machine learning is further divided into two parts: classification and regression. Classification, the training data that we are feeding to the algorithm includes the desired solution called labels, right? The classification of spam filter is a supervised machine learning task, the one that we just talked about. It has basically a label saying this email is a spam, this email is not a spam. So we had already had the data in which each email was marked as spam or not spam, and we are feeding that to the algorithm. So this is called classification. Classification is basically categorization given the historical data on the categories. Okay, in classification you can think of it as if it's a multiple choice question, right? Multiple choice question whereby you have to choose one of the classes, right? Similarly, it's a multiple choice question for the computer that it will be trained, and then we'll be asking that which of this is right, whether it's a cat or a rat, right? So those kind of the tasks, the projects or the problems, the tasks that involves classifying something into predefined categories, or the training data that has the label in the form of categories is known as, I mean, that those problems are called the supervised machine learning problem. Let's move ahead. The good example here is that given the incoming emails data, let's say some people had already marked some of the emails as spam, some of the emails as not spam. So if we had this data already, whereby the data was marked already that this particular email is a ham or a spam, then basically this problem is classification problem. Okay, it's a classification supervised machine learning problem. So spam filter is an example of supervised machine learning, right? I'll talk about something called clustering, which is not really like classification, because here we have the label available in the training data saying that this belongs to this bucket. Okay, the training data. Now, the other kind of supervised machine learning whereby human is training the machine. All right, I think I jumped ahead. Now, human is training the machine, that's called supervised machine learning. Human as in we have the labeled data. We have already labeled it and we are feeding that to machine, right? Now, supervised machine learning, one of the things is the one of the supervised machine learning was the classification. The other one is regression. In the regression, the kind of problems in which we have to predict a value instead of a class, instead of a category. We are predicting some number, some value, some string. That's called the regression. Generally in the regression we predict a number, a decimal number or an integer number, in order to get that's the task. So if the problem statement involves predicting the number from the data, and we already have the data whereby the value, each data is tagged with a particular label. That kind of problem is known as supervised machine learning problem. For example, here, let's say you want to predict the price of a car. And what you did was you went to all the websites which are selling the car, you downloaded their features, and you built this data set that contains all the features of all the cars, and there is a label or target which says the price of a car, right? So this problem is called as supervised machine learning problem, that too a regression, because we're trying to predict a number. So regression is basically predict the price of a car given set of features called predictors such as mileage, age, brand, etc. To train the model, we have to give many examples of the car, including their predictors and labels. So basically, we have the features of all the cars as well as we have the price of all the cars, right? This is available in the dataset so that the model learns to predict the price based on the characteristics of the cars, right? Now, that was supervised learning. In supervised learning, you have the target or the label available in the input data. So such kind of problems are called supervised, where you have the label already available. There is another category of machine learning called unsupervised. That is basically something really difficult and something that is yet to be explored in way more detail. All right. Now, in unsupervised machine learning, the training data is unlabeled. Okay. So there are two chapters in which we discuss unsupervised learning. One is the algorithms, and the other one is the autoencoders in neural network, right? So in remaining part of the course is around supervised machine learning. So unsupervised machine learning doesn't have a label. That might sound very crazy to you. Let me just give you more example. So training data doesn't have labels. The system tries to learn without a teacher. And the problem statements are like this. Given this data, this is my users. Tell me something about my users. Here are some transactions. Tell me the outliers in these transactions, right? Similarly, it could be something like that there are files on my desk. Can you arrange them in 4 buckets? And you might ask, like, on what basis? And the person might tell you back that whatever you feel is right, just put them in 4 buckets, right? This is unsupervised machine learning problem. Given the data set, finding a pattern in them, organizing in some order or in some mechanism, the model comes up with a certain pattern, and that's called the unsupervised machine learning. Unsupervised machine learning, mostly the clustering is there, but there are some more algorithms that I'm not going to talk about here. So clustering problems are the most common problems in unsupervised machine learning. Like, for example, given the history of all my visitors in a blog, can you just create groups of these users? Can you group them? And you say that, okay, on what basis? And the person says, I don't care, you just group them. You just figure out some basis on which to group. And then you say, okay, how many groups? Then the person says, whatever groups are most optimal, right? And therefore, this problem statement that group my users of my blog into some buckets is basically an example of unsupervised machine learning problems, right? And these are the hard set of problems. It's not that obvious upfront, okay? Right? Next is clustering. Okay, next is clustering. Sorry, let me go back. Yeah. So, so clustering or unsupervised machine learning problems are those whereby we detect certain pattern. Like for example, here in this example, we detected the we that detect the group of the similar visitors in the blog, and notice that the data in this training set is not labeled. Okay, so we to train the model, we just feed the training set to the clustering algorithm. At no point we tell the algorithm which group a visitor belongs to. So the algorithm themselves comes up with some patterns in the data on which it needs to group them. Okay, it looks at all the characteristics of each user, for how long they're staying, which pages are they staying on, how much they are paying, are they subscribing or not, and so on. Based on that, it would come up with the various buckets, and those buckets could define your users, and maybe you can just label them, put the name around those kind of users. Like for example, if you look at your Gmail account, it has social updates and so on. That's basically come up with, given an inbox, come up with 4 buckets, and those 4 buckets will give the name later, and then they came up with these names probably later. Okay, so this was an example of unsupervised machine learning. Unsupervised machine learning is something that is very important and is little harder. Okay, all right, so okay, so let me just complete this part, and then we will carry on to the questions. Okay, so some of you might have asked questions, so let me take a look at the questions. If those are right, critical, I can answer those questions now. Just give me a moment. All right. Okay, so all right. One of the questions that is coming up over and over is that is there a certificate for this particular webinar? The answer is no. It's an open session for all, and therefore there is no certificate for this webinar. All right. All right. I think the more than the certificate, you would appreciate the knowledge that you would gain. One of the questions that is being asked is that what is a training set? Training set is essentially the past experience or the data that we already have. So if we have the data of all the emails subject, and there's a frequency of this user being sending, so all the characteristics of the email, so we break it down into columns and rows such that the columns are the features of every characteristics of every example, and the rows are the examples. Each row is an example, and the columns are the characteristics. So that's one of the things that we'll learn very soon, that we break down the past experiences into a tabular form, whereby the columns represent the characteristics, features, or you can say attributes, or sometimes we call them discriminators. And so columns, features, and or attributes go in the columns, and the features, attributes, and characteristics go in the columns, and the rows represent the experiences. And one of the columns is a label, right, in which we say that this particular email is spam or a ham. Okay, so that's something that we will learn very soon. And so we have the data set in this tabular form, whereby the rows are the experiences and the columns are the characteristics. So generally, when we are training a model, we break this data set into two parts, training and testing. And, and the training part is something that we teach the algorithm. The test part, we don't show it to the algorithm. Otherwise, it will start learning from the test, right? The test is used for checking whether the algorithm is learning something well or not. So we randomly pick a test part from these experiences, the example data. So we break the data into two parts, training and test. We train the model on the training and we test it on the testing data set. So that is something that's a machine learning process. And the way we do is, right? So essentially, we basically don't let the algorithm see the test data set, and we only run the algorithm once it is trained on the test, just to compare the value against the actual ones to understand whether an algorithm is learning properly or not. Okay, so that's how the machine learning process looks like. Now, the another kind of unsupervised machine learning is hierarchical clustering. Hierarchical clustering is giving the characteristics of objects or examples, create a hierarchy. Create a hierarchy of the objects or things or ideas. That's called the hierarchical clustering. Hierarchical clustering, a very good example in front of you is that what biologists such as Darwin, what they did was they arranged the species into a hierarchy based on their characteristics. Based on their characteristics, like whether they are mammals, whether they are not mammals, or how many years do they live, how much do they weigh, what do they eat, and how many legs they walk on, do they, and so on. So they came up with all these characteristics of every animal, and based on this data, they categorized that into into the clusters which are hierarchical, right? And this is one of the hardest things for a computer to do. You will see that when we run it on an example of cars. Okay, so coming up with this structure based on the dataset's characteristics is called hierarchical clustering. Hierarchical clustering. And this hierarchical clustering takes a lot of time because it needs to do all kinds of permutations. And it needs to come up with the way to classify or cluster the objects such that the things that are together in the same node of the tree, they should be more similar than those which are away. Okay, like for example, human and chimpanzees are are siblings in this hierarchy, right? So this is called hierarchical clustering. It's an example of the unsupervised machine learning. The other unsupervised machine learning example is anomaly detection. Given the credit card transactions, come up with the fraudulent transaction. Right now, we don't know which ones are anomalous. Just here is the data, just figure out which ones are anomaly. And this way, we generally detect even the fraudulent transactions by looking at the anomaly. So this is called unsupervised machine learning, where we don't have the label. The next one is the reinforcement learning. The reinforcement learning. The next one is the reinforcement learning, and in the reinforcement learning, the example that we took in the beginning is an example of reinforcement learning. The Mario example is a reinforcement learning in which the actor observes the environment, right? It selects an action using policy, using whether to go left or right or jump or don't go anywhere. That's an action to be taken by the actor. Actor in this case was Mario, and the policy would have been something that is trained with. Then that's a machine learning model, the policy is decided by the model. The action is about what to do, whether to jump, go left, go right, or stay there. Then get reward or penalty, right? So there is a definition of a reward or penalty. When Goomba jumps on it or the points go down, that's a penalty. When your points go up, that's a reward. There's a update policy, as in learning step, as in what we do is, so the most interesting part about reinforcement learning is it is learning and predicting, both the things happening at the same time. Like how? So in the beginning, we inject the player into an environment, let it play random moves. Let it do random moves and let it play this way. Now we have data from those 100 moves that with these moves it succeeded, with these moves it failed. So from that it learns. Now it learns from that data, and now the player is injected again 100 times using this algorithm that is learned, and then again the new data set it has learned, basically we train on that one, and then we keep on doing over and over this part, and this essentially improves its game over a period of time. So while it is playing, the game is essentially recording everything it's doing, and once the game is over, it's learning from that and then getting into the game again. So update the policy, that's the learning step, right? That's where we retrain the model and we iterate it until an optimal policy is found, correct? So the player observes, select an action using policy, and then takes an action, it gets a reward or penalty, and then it will update the policy in a learning step. We call that learning step. So and then we iterate until an optimal policy is found, right? It's like you wake up every day, play in this environment, and whatever learnings you have, you go back to the sleep, and then you are updated next morning, and then you again start playing. So exactly, this is reinforcement learning. Reinforcement learning is something that you all can connect very well, because this is what we do. We learn and predict at the same time. We are learning, and afterwards we are applying the same learning. We are learning a taste when we are going to a new restaurant, and then next time we are predicting that whether this is tasty or not. So this is exactly what is reinforcement learning. The learning system, in reinforcement learning, the agent observes the environment, selects and performs an action, gets reward or punishment, and learns by itself what is the best strategy to get best rewards or minimize the punishment. There are so many examples of reinforcement learning today, like for example, the robots that learn to walk. The AlphaGo that defeated the champion Lee Sedol in the game of Go basically was trained to play Go by itself, by giving it an environment and playing against itself. And it kept on playing until it figured out the best way to play the game. So it kept on playing by itself and then learned how to play it. This is called reinforcement learning. All right. Wonderful set of questions, and feel free to ask questions using the chat. I'm really happy to see amazing users on our channel right now, and I hope you're finding this session useful. So far what we learned was that machine learning based on the task can be classified based on 3 different criteria. whether it requires supervision, whether it is learning incrementally, or how well they generalize, right? So based on human supervision, it is supervised, unsupervised, and reinforcement. And further, we talked about their categories. So given these characteristics of the problem, you can see that, okay, this is the problem, and since it has a label, it is going to be a supervised machine learning problem. And since we have to predict the class, therefore it is classification. Since we have to predict a value, therefore it's a regression, right? If it doesn't have a label and the problem statement involves like, given this data, can you organize it into some folders, or given this data, can you just come up with three categories or four categories, or come up with optimal number of categories, or can you come up with a hierarchy given this data, right? So that's called unsupervised learning. Reinforcement learning involves continuous learning and predicting. So reinforcement learning is an iterative loop of supervised learning because it has the data generated as supervised, right? Now, the second way we can categorize the machine learning problems into the whether we have to learn incrementally or we have to do batch processing, right? So you can see it here. Are you able to see it clearly? So the way it is that we study the problem, train the ML algorithm, we evaluate the solution, and then launch. So here what's happening is that the after launching, the training is not happening on the real-time data. We are running this flow separately, and the system in live is running as is, right? This flow is called batch learning. We have a lot of data. We are training it in our maybe a very high-end systems, and then pushing it to the production real life scenario, the where the user is coming, or a production as in where it has to continuously predict. So here, in case of batch learning, the prediction will happen very often, but training will not happen that often, right? So in batch learning, we have, it's called offline learning. Like we generally run the training, we have the data on our high-end machine, and we basically train it on that data, and then we basically deploy it to the production, right? It doesn't learn in the production, right? So basically it's offline learning. System is incapable of learning incrementally, and it must be trained offline. It takes a lot of time and computing resources, but the important part is batch learning is the most common form of learning that you will find, right? Once the system is trained, it gets pushed into production, and it runs without learning anymore and just applies what it has learned offline. How to train the system with the new data? We cannot train the system incrementally. We have to train the new system from the scratch on the full data set, right? We stop the old system, deploy the new system. The limitations is it takes a lot of computation time and so on, but this is something very popular. The other kind of learning is online learning, right? So you basically train an algorithm online, as in when the data is coming, and notice it here. We trained it, put it, evaluated it, and then put it into production. We launched it here. And as the new data is coming, it's running, as in predicting, and the learning, predicting and learning, predicting and learning. This way, the online learning is happening. So if your problem statement is that data will not come right now, data will come at later point of time, you will have to keep learning and deploying, keep learning and deploying automatically, those kind of problem statements are called online learning. So we train the system incrementally by feeding new data sequentially or in branches. System can learn from the new data on the fly. Humans do the online learning all the time. We keep on learning. It's good for systems where data is continuous is in a continuous flow, and like for example, new stock prices are coming, and it has to predict whether it's go up or down. It can't really rely on the old mental model it had prepared, right? So, using online learning, we handle huge data sets, lots of data. We put it into pieces, and we basically train online algorithms as and when the new data is coming, and so on, right? So again, coming back to what I'm saying is that the other use case of online learning, other than, let's say, you have a problem statement in which you have to online learn as and when data is coming, and whereby you don't require entire data in a single shot. Usually in most of the machine learning algorithms, you will find that the algorithm is trained on entire data set and it is not trained incrementally. But in lots of new algorithms, you can train the model incrementally. You feed in parts. You basically, if you have lots and lots of data, instead of feeding the entire data to the algorithm, what you do is take it into pieces and keep feeding it, right? And this way, your algorithm can keep learning from the parts. So you don't need to really feed the entire data on the day zero. And as more and more data is being fed to it, it is becoming smarter and smarter, right? So this is something that the other use cases of online learning. All right. Using online learning, we can handle huge data sets, right? If the data is not fitting in the memory of the computer in a single shot, it's better to break it down into parts and train the model on that part, and train the system incrementally on each part. The challenges in the online learning is systems performance might gradually decline, because if there is a newer data which is bad and the older data is taking a less priority, then what will happen is your system will start performing bad if the bad data come in the recent times, right? Or let's say someone is spamming your system. If they figured out that your system is learning online, they might spam your system. As well as there could be a sensor recently that is not performing well and is sending bad data. That way, since the most recent learning is taking the precedence, what will happen is that it will start to forget its roots, and therefore it will start performing bad. Now, the challenges in online learning is it closely monitors the system, right? So when you have online learning system, you need to take care of the system, because you have to closely monitor it, because in case there is data fluctuation or its performance is degrading suddenly, you have to stop. You have to monitor continuously and remove the anomalies. Most of the machine learning tasks. All right, let me go back to the diagram. Yeah. Now, the next way we separate the machine learning is based on how well they generalize. How well they generalize. That's how we categorize the machine learning problems or machine learning algorithms, based on how well they generalize. So we will take a break here for 10 minutes. Okay, 10 minutes break. We will be back by 9:43 p.m. IST. Please post in the comments the time in your time zone if you are from other country. Alright, so I'm back. Let's start. This webinar will start at 11 p.m. Alright, and this webinar is around the machine learning, and it's an introduction to machine learning and AI. So far, what we have discussed is the about the course, of which this is the first open session. Open session, as in, is basically for everyone. And from the next 6 June onwards, it'll be only for the people who have enrolled already. On the next or coming Saturday, that is 6th June, we will be having the session by all the instructors all five introduction instructors. We will have introduction by all of them, and you will get to know all of them so that you can get familiar and hence improve your learning and engage with the professors and the instructors from the 6th June onwards. This session is for all. This one is on YouTube. The next session, 6th June, is going to be on Zoom. The subject of that session is going to be the same as today, but by various professors. All right. Now, so far we have talked about on what basis do we categorize machine learning. First one was whether the task requires human supervision or not. Second one was whether we in the particular machine learning task we need to learn incrementally, as in when the data is coming, or we have to learn in a single go. All right, it's a function of two things. One is what kind of data do we have, as well as what kind of job requirement do we have, as well as what kind of algorithm are we using. So learning incrementally, whether online or batch processing, is a function of three things: the requirement, the size of data, and the algorithm that we're going to use. All right, we will show you a couple of examples of that, and you will get a fair amount of idea what we're talking about when we do more hands-on. And right now, I hope the idea is clear to all. Also, somebody has asked about more examples of supervised learning. So more examples could be giving a photo of a person, predict whether the person is a man or a woman, or giving a photo of a person, predict the age of a person. When you're predicting the age, the task is called supervised machine learning regression, right? It's called regression, which is a supervised machine learning task. If you're predicting whether the person is a male or a female, that's a supervised machine learning, but classification, right? While unsupervised machine learning involves categorizing things into buckets where buckets are not pre-known to you. All right, now let's move on with how well the models generalize. So this concept is a little harder to understand. Okay, so uh, essentially, how do we generalize well? That's a very, very important part. And there are two kinds of machine learning as based on how well they generalize, as in, I am good at coding in Python today. Can I code in, say, a new language called Julia, right? Can I code in a new language called Go? So am I able to generalize my skill set? That is called generalization, right? Or look at it this way, let's say there is an individual who is living in a village. Can he, when he comes to the city, can he survive there? Is he able to generalize well? Is he able to also solve or predict the problems in a new environment where it was not really trained, right? Or can he generalize on unseen data well? Okay, so that's a very, very important part, and the way we do this is essentially uh, uh, there are two different kind of ways we basically have, like first one is instance based, whereby given a new instance, which one it is closer to, right? Which one it is closer to, we find that out and we apply. Like for example, a lot of faiths could not figure out, lots of people could not figure out whether whether they can use electricity in their fasting days, because in their fasting days, I think there's some ceremony in Jews or so they couldn't figure out whether they can use electricity on the fasting days because they were not allowed to use fire. So is fire similar to electricity? So given a new instance, we try to figure out what is closest to it. So given electricity, we try to figure out whether it's closer to fire or not, right? So similarly, so given a new situation, we basically try to take a similarity to the nearest one and do according to that. This is called instance-based learning. Instance-based learning, right? Instance-based learning is essentially about finding the nearest experience or nearest example dataset and acting like that, right? For example, here if let's say, okay, so given a new instance, it will try to come up with this one or that one, and so on. This is new instance. Now basically it's trying to come up with, here we are trying to separate the squares from the from the triangles, and given a new instance, we are trying to see which one is closer, this or this or this, right? This is basically called instance based learning, right? Instead of coming up with a generalized model, we are seeing the similarity between the experiences and so on, right? So most trivial learning by heart or memorization, system learned the examples by heart as is, and then whenever it sees new examples, it tries to see which one it is closer to, and whichever it is closer to, it just thinks that it is like that, right? Like for example, let's say we are comparing the we are trying to predict whether something is a cat or a dog, right? So it basically takes the new photo of the dog and tries to compare it with all the other photos, and then sees which one is the most closest to it, right? That's essentially the instance based learning. Instance-based learning is because it doesn't come up with very good results. So spam filter, let's say, flags an email that are identical to known spam emails. Also, the emails which are similar to known spam emails will get marked. This requires measures of similarity between two emails, and a basic similarity measure between two emails can be count the number of words they have in common, right? So this way we could come up with the new prediction whether something is a spam or not a spam based on comparing the new email, the one that we are trying to predict, against every email and see which one is closest to that, right? There are two problems with this approach. First one is it's extremely slow because the bigger the training set you have, the bigger the data you have to compare it with again every new instance, you have to compare it with all, right? Now, basically, this is basically something that would fail badly in this case. For example, let's take a case of this example, right? Imagine something being here, right? Instance-based learning will say, okay, something is here, which is say closer to this one, or let's say something is here, which is closer to this one, and therefore it is square, not a triangle, while it's falling into this particular model. So what I'm trying to say here is that the model-based learning is about coming up with a mental model, like this, okay, coming up with a mental model like this, and putting a new instance here, and then comparing it with the instead of comparing with the nearest one, we come up with the mental model like this, right? In a instance-based learning, so imagine that. Okay, let's go back to here. Here, the task is that given a point, given a example where, so on one side we have some feature, on another side we have some feature, given a particular point, whether it's a square or a triangle, let's say that's the task we need to perform. Okay, so when we do instance-based learning, we take this point, see which one is closest to, is it closest to the square or is it closest to the triangle? If it is closest to the square, then we call it a square, otherwise we call it a triangle. That's called instance-based learning, like here. We take a let's say we put a point here, so we say that okay, this is near to a triangle, all the things that are around are triangle, while the squares are way away, therefore everything here is going to be a triangle, not a square, right? And that's called instance based. While in the mental, in case of model based learning, we have a mental model. We have a mental model like this, although it was supposed to be round, not this way. So imagine that we have a mental model that there is a circle that separates the triangle and a square. Therefore, when we put a cross here, so instead of taking it similar to this squares, we'll say that as per the mental model, it is here, right? It is here, and therefore, this particular instance is triangle, not square, right? Instead of measuring its distance from all of these and saying that okay, since the closest ones are these, we are not doing that way. That is called instance based. Here we have a mental model. We have a mental model saying that there is a curve that separates the triangle and the square. Anything this side of the curve is a triangle, on the other, right? This is called model based learning. Model based learning is based on the model, based on certain mental model, whereby we have come up with a mental model which has certain kind of boundary, and that's called the model based learning. Model based learning is extremely fast because all you have to do is check whether this point is to the left or to the right of this line, right? Is it inside the circle or outside the circle? This is called the model based learning, right? Model based learning is something that we devote a lot of time on, and model based learning is something that we would focus a lot on. While there are some instance based learnings, for example, we will study decision trees. Decision trees are basically an example of instance based learning, a little smarter way, not as dumb as this, but little smarter. So model based learnings are generalizing well, right? While instance-based learnings do not generalize that well. And therefore, mostly we favor the model-based learning. Model-based learnings are faster. When given a new instance, we basically come up with, come up with this very lightweight line. This is our mental model that we have prepared, that okay, there is a circle around our data. This is the mental model. So we only have to memorize this circle. And the moment a new point we see, we can quickly say this is inside the circle or outside the circle, right? This is called model-based learning. Model-based learnings are around the model. There is a model, there's a mental model, there's a circle, there's a line, there is a plane, there's a hyperplane that is predicting whether something is a triangle or a square, right? While in case of instance-based learning, we are memorizing everything. Whenever we see an instance or a situation, we compare with all the situations that we have gone through, and then we see, okay, this looks like that, and therefore it would be that, right? These kind of learnings do not generalize very well. Okay, we end up being and if you look at most of the human misery is because of the instance-based learning, that it was supposed to be the best Christmas like the way we had last year, or the Christmas is supposed to be celebrated exactly like this, or this should be done exactly like this. But a model-based learning is, why are we celebrating something? There is a mental model around it, right? Why are we celebrating? Can we do it this way? Like in case of lockdown, how would you celebrate a festival? Because you have not seen similar situation in past, and therefore the instance-based learning would keep on failing, that how to do this in case of lockdown, because we have never seen such a thing in past. Therefore, a model-based learning, model-based mental model, model-based learning is way better, because we have a mental model. Because let's say that, okay, in case of I mean, the purpose of say celebrating is being happy and being with friends, and therefore let's have an online party, right? And hence, so a model-based learning is a more reasonable approach. We have a mental model, and we basically follow that mental model, right? So these two things, instance-based and model-based learning, we will cover in more and more details, and you will see that that the machine learning that we'll study in this course is more related to the human behavior and human psychology, and you will see it more and more as you'll go ahead. Most of your decisions and the other complex mechanics are around predicting things, and how you predict, on what basis do you predict, is something that basically leads to all kinds of results. So we'll study this in way more details as we go ahead. We'll figure out how to do which one, and we'll see which one is performing better, and we'll use a combination of instance-based learning and model-based learning. Sometimes we will entirely discard the model-based learning, and we will entirely discard the instance-based learning and follow the model-based learning. Instance-based learnings are great when we are not able to come up with a model. When we are not able to come up with a model, then we memorize, and therefore that's how we do, right? So coming back to it, basically this is the third basis of this is the third way of categorizing machine learning itself, based on how well the models are generalizing, whether they're memorizing and then comparing, or whether they are doing model-based learning, right? And you will see this more and more. We have examples where people think that they are doing machine learning, but they're essentially doing instance-based learning, comparing everything with everything, and saying that they're doing AI. And you will get the more clarity as we go ahead. All right? Now, wonderful set of questions, and I'm really happy to have all of you here. All right, moving ahead. So another way to generalize from a set of examples is basically we are describing what exactly is model-based. Let me just go through this once. Probably those who could not get the previous one, let me just reword it. Build a model from the example experiences. So past experiences, whatever you have, you build a model around that. And then use that model to make predictions. This is called inference. And this got inference, and hope that model will generalize well. Okay, so we will learn more about what does it mean by biases in case of machine learning, as well as human. What does it mean by biases, and what does it mean by variance, or we can overfitting, underfitting, what is too much learning, what is too less learning. We will study and in more details as we go ahead. And we'll demonstrate to you that what it means by not learning or learning too less or learning too much by the way of practical example in the next session. All right, now the next thing I want to discuss briefly is the artificial neural network. Artificial neural network, or ANN, is basically a computing system to do predictions which is inspired by the biological neural network that constitute the animal brains. So computing systems inspired by the animal brains, biological neural network that constitute the animal brain, so basically is known as the ANN, or artificial neural network. All right, it's not necessarily the way animal brain functions. No, it's different. It's a little different from the way it is trained and so on. But the idea originated there. Idea originated there. For a very long time, this domain was not moving ahead for a very long time because of multiple reasons. One, hardware not being available, soft data not being available, and the algorithms were not that great. In recent years, there have been breakthroughs in the neural networks. There have been breakthroughs in the way we train a neural network. There have been breakthroughs in the way we regularize the neural network, and that has led to amazing breakthroughs in the machine learning vertical. This is the reason why machine learning has become the mainstream now. Machine learning has become mainstream now because the neural network have become mainstream. The, 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 the kind of predictions that a neural network can do was not something that was possible with previous techniques, right? And very complex systems can be built, like face recognition, natural language processing can have been built using the neural networks. That's the reason why we are studying, the reason why these neural networks have become the mainstream. One, we have a lot of data for training, we have a lot of processing power for training, and the algorithms have become drastically faster to train. And next is, we have come up with many optimizations that even less number of training would result in better outcome, better model. So basically, the deep learning is essentially to learn to do tasks considering examples, generally task not task without task specific programming. For example, based on an image, we have to predict whether it's a cat or not cat. So deep learning is essentially using a neural network. Okay, so we will go into more details on exactly how neural network is. All right, so machine learning is essentially, we have a black box, or you can think of it like a model. We give it data, it learns from the data, gives out model, and then with that model we run it on the real data to do the prediction, right? That model could be of various kinds. That model could be as simple as, memorizing everything in the past. That model could be as simple as drawing a straight line between the data. We call it like linear regression. That model could be based on other models such as decision trees, as well as some more, right? Now, the same model could be of something called artificial neural network. So the way these machines are learning is the way neurons are learning. Neurons in your brain are basically right, like this. So they have inputs. Imagine that this is a neuron, okay? It has a input, right, coming from the eye, like a sensor or visual, and or you can say that this is the eye, it is receiving all the light from outside. This is a neuron, it's receiving the light from all of these and then giving out some output, right? It's adding it, multiplying it, whatever it's doing is doing it here and then giving it, right? This is called neural network. So essentially numbers are coming here, it's adding or basically it's multiplying all these numbers with something called weights. The thicker the edge is, the more will be its strength, and it'll multiply this the strength that is coming here and then sum it all and then give out. Okay, so this is what it does. Okay, so I'll give you a better example. Okay, all right. Okay, let me try to give you an example. When you go to a new hotel or a new lodge or a new guest house where you have not been to earlier, and it's there is a knob in the bathroom and you need to take bath, right? So on one side the hot water is coming, on the other side cold water is there, right? And before every bath you tweak this knob. Before every bath you tweak this knob in order to come up with that position where the water from the shower is good for you, right? In the winters this would be like a full, it takes maybe like 2 minutes of your time. It's just too hot, you go to the I mean too much left is too hot, on too much right is too cold, right? We do that all juggling all the time, right? So this knob represents this knob represents that neuron. Okay, it's getting the inputs, hot water, cold water, and the algorithm is tweaking this knob. It's basically trying to go to the left slowly and then see whether it became too hot. If it did not become too hot, then it'll keep going, otherwise go to the other side, right? Exactly the way you would do this, exactly the way you would tweak this knob, exactly this way you will tweak this knob, the machine, the computer algorithm would also tweak this knob. So essentially a neuron is a knob. It gets signal from all the inputs and we tweak it. We keep tweaking it, and we tweak it until we start getting good results, right? Now here in this example the difference is that the lines that are drawn, these lines that are drawn here, you see these lines, these are the knobs in a neural network. Basically when we are training the neural network, we're basically tweaking these knobs. These knobs are being tweaked all the time, so until we get the result that we're expecting, right? So again, let me describe the knob. This is extremely important, and you'll get a proper idea. All right. So you have input coming in, hot water, cold water, and you're tweaking this knob so that you get good result. Now essentially this is hot water, this is cold water, this is salty water, this is acid, this is basic. You can imagine like this, there are multiple kind of outputs coming, and these lines that are drawn are actually the knobs. So you're tweaking these knobs until you get proper water, right? And so on and so forth. So the one thing that people had figured out is that if you layer these knobs over knobs over knobs, you can achieve anything. Not only hot water or cold water, but also things like what alchemy did, right? You could achieve like tea or coffee or anything, right? By combining the right mix of the inputs. Coming up with those right mix of inputs is something that we do that. We basically tweak these knobs until we get the right mix of output, right? All right. So this example that I've taken is extremely simplistic, and I wanted to make sure that we all understand it, right? So the way we tweak the knob of bathroom in order to get the right temperature, in the similar way, we tweak the neurons, we tweak the connecting lines of neurons until we get the right results. And that's the holy grail of the entire deep neural network. You can imagine the neural network as lots and lots of knobs that are going to be tweaked. Given this photo, we have to predict whether this photo is of a cat or a dog, right? Cat or a dog. Let's say given a photo, we want to predict whether something is a cat or a dog, right? And there is a big neural network. There's a big neural network over there, and these neural networks are nothing but lots of knobs, and the input data is not hot or cold water. Instead, it is lots of information. The whole picture, the whole photo is being fed. Every pixel is being fed as input, right? This way, by tweaking millions of knob or billions of knob, we can achieve anything. This is the main premise of the deep neural network. As we study further, since it's for all the audience, I want to keep it extremely simple and want to have everybody on the board. Even if you have never been to computer science, even then, I'm hoping that you will be able to uh, basically correlate what exactly is neural network in this case. All right. Now, coming back to again, let me define. There are two kinds of neural network. One is simple neural network. Other is deep neural network. Okay, deep neural network. Now, this is called input layer. Like your eyes are receiving signals, right? So this is your eyes, right? Why there are 1, 2, 3, 4, 5? There are a billion uh, input neuron in case of your eyes, because there are billion neurons connected to the eyes that are receiving the entire photo, right? Now, this is the input layer, right? This is the hidden layer, right? And this is the output layer. Output layer in case of algorithm, output layer is given the, let's say we are trying to classify the photo into 4 categories. Okay, so these last layer represents how many categories do we want to segregate this data. Okay, if we are trying to predict only a number, if it's a regression, not a classification, there will be only one output here. This one will be the output layer. Okay, so there will be only one neuron in case of regression, while in case of in case of regression, there will be one neuron in the output layer, right? And this output layer represents how many classes are there. Imagine we are only separating cat from not cat. So this is cat and this is not cat, right? There will be only 2 neurons here in such case. If let's say we are trying to distinguish between cat, dog and neither, right? So there will be only 3 neurons here. Okay, there will be only three neurons. So based on number of things that we are trying to predict, the number of neurons in the output layer will be decided based on how many things you are trying to predict. If there are 50 classes of object that we are trying to predict, there will be 50 neurons here. And this one represents what kind of output do we have. What is the size of input do we have? Input layer is a function of that. Output layer and input layer are function of the problem statement. What kind of data we have, what kind of things that we are predicting, right? And the hidden layer that you see here, this hidden layer is our choice. We choose how many ever we want until we get the right results. So we come up with more number of these and so on. So simple neural network only had one layer. This is called one layer. Only one layer of hidden neurons. While people figured out later on that if we have more number of layers, if we stack all these knobs, these are the knobs, okay, these are the knobs that get tweaked. If we keep on stacking them, we will get the right results. Okay, we will get the good results. That's what people figured out, and that's where the deep neural network came into play. This is the input layer, this is the output layer. It is up to us, whoever is the engineer who is training the neural network, to decide on how many neuron per layer do you want, or how many layer would be good. So you experiment with different number of layers and different number of neurons in each layer and figure out which one is performing better for you. Okay, so there is no single thumb rule for that. We will we will study how to do it exactly at later point of time, but for now understand this, that there is input, there is expected output, and there are knobs in between. Billions and billions of knobs. Objective is that come up with that configuration of knobs such that given an input we can predict the output correctly. Given an input, we can predict the output correctly. And that's the entire deep learning in a single sentence. We will study how to do this as we go ahead. Now, everyone across the globe is using machine learning or deep learning today. BuzzFeed is predicting what food to recommend to the user, and what food will sell, what is the price. Airbnb is predicting the prices and so on. Optimizely is predicting the images size and so on, while the Google is predicting the Google Photos, Pinterest is predicting the photos that people will like, and so on. So everyone is using deep learning today in order to do the prediction. And most of these predictions are amazing and very, very interesting because we do not understand how it's coming up. We do not understand how it's coming up with so good results. And it continues to surprise almost every data scientist. All right. There are other more detailed use cases. You can take a look at the, okay. You can take a look at AI experiments with Google. You'll find lots of use cases, right? So today, even converting voice into text is basically a deep learning problem. So you give basically, if you look at the problem, like given a voice, predict the word, right? Given the voice, predict the word the user is saying. Okay, so the input is the sound. Sound is nothing but sequence of numbers, and we feed this to the machine, and the machine basically converts every sound into a syllable or the letter, and that way, or let's say we have a dictionary of 1,000,000 words. So on the right hand side we will have a, right here, so here this will be the sound. Let's say we are feeding the sound. This is input layer. We will be feeding the let's say we are having clips of 1 second each. In 1 second, if there are, let's say, 44,000 audio signals, we are feeding that, and we are here, let's say there are thousands or thousand syllables we are predicting. Given a sound, predict which syllable was spoken in this sound, right? Given a sound, given an audio clip of 1 second, predict which syllable was spoken, right? So this is the voice recognition system, right? Now, to the data scientist, the question will be that given this 1 minute clip, we are feeding the clip here, right? The voice signal. Predict which label was spoken. Come up with number of neurons or number of layers. It is your choice when you are training model that you come up with these layers, right? It is like putting more and more in the bathroom, right? The way you had one knob which you tweaked in order to come up with the right set of water. In case you have complex requirements, you have to put more knobs. You have to keep putting more knobs. So all of these you see is basically a software construct. It's basically a software construct. We take this data, multiply it by something, then add it, and so on. So it's a software construct, but visually this is how you can imagine that we are going to tweak these knobs such that we can get this label or get the output required given the audio or any input, right? So in case of a voice recognition system, you feed the sound signal here and you observe what syllable was spoken, right? And since you will have the training data already that this sound is for this label, this sound is for the, let's say this some sound for some label, some other sound for some other label. Since you will have that, what you will do is actually that for given input and for expected output, tweak these knobs. For given input, expected output, tweak these knobs. And that's what is called training. Tweaking the knob is a training. This, when you are tweaking this knob to get the right set of right temperature water, you essentially training this knob, right? And the position, this position is the mental model. Next day you're going to take bath, you'll remember that okay, the temperature is this much. Or let's say you applied the soap and you again want to turn on and you know that this is the position that I kept last time. So you only have to remember this so that you don't have to train again, right? Similarly, a model once trained essentially is bunch of numbers, positions of those knobs is what it is, okay? And all you have to do is when we say model, it's essentially those positions of the knob that are saved in a file, and that file is called model, okay? So these things are essentially those positions of the knob, okay? And I know that I'm oversimplifying, but as you study further, as we go further, we will go into more details exactly how can we build a voice recognition system, or exactly how can we build a face recognition system using the deep learning that we have studied so far. Okay? All right, and similarly, you can take a look at here. Right, so you can take a look at here. There are lots of collections of examples, and you might want to play around with lots of very wonderful things. Okay, now coming back to it. The other example that you might want to go through is the TensorFlow playground. Right? So here there is an input layer and there is a neuron. So you can do an experiment with it, and it'll figure out from this. Oh, I'm not able to post it because for whatever reason. You could, I'll just share this link with you. Oh, okay. Yeah. Try it out and you will see that it is able to do wonderful things. So if, for example, this is the data, we know that this one is green color, this is a blue color. The system it basically is trying to figure out a model, okay, and you can say, so it figured out a model, that this is the model, right, which predicts whether something is this or this, right? So coming up with these models, coming up with those mental models that can predict one class from another class is basically a supervised machine learning problem, or you can say that this is what the deep learning is really, really good at. Even the very complex scenarios whereby most of the algorithms used to fail to detect the pattern, the deep neural networks are able to come up with those patterns. A question that is very frequently asked is how do we decide how many neurons to choose, how many layers do we choose? Okay, so here very quickly I'll just do answer this question very briefly, because this question is extremely hard, and it would take a long time probably as we study in the class. This is the optimization that we will learn. So basically, when we add more layers, or when we add more layers, the neural network keeps on becoming complex. It can solve complex problems. When we have a smaller neural network, then it can only solve very simple problems. Like this one can only figure out a straight line in the data, right? While this one can solve really, really complex problems. Okay, and therefore, the more complex problem you have, you will start increasing the layers. If increasing the layers is not solving the problem and it's becoming more and more, it's memorizing and its performance is degrading, then you go back and start increasing the number of neurons. We will study in more details that how to balance the two, and we'll study in further like what else can be done other than increasing the layers or increasing the number of neurons in each layer. Okay, there are many things that can be done, and many things that would be done. All right, so this is something that neural network does, and all right, there are many deep learning frameworks today. One of them is TensorFlow. That's the one that we're going to use. We are having one chapter on TensorFlow 1. Remaining chapters are using TensorFlow 2. The beginning 7 chapters revolve around scikit-learn. We'll talk about that soon. We are not going to use Theano, Caffe, or Torch. We are going to use Keras API in TensorFlow. TensorFlow 2 is essentially uh, it's the API, the function calls, and everything are as if they are from Keras. So because Keras had one of the best simplified, simple model to train the create the layers, add neuron, and so on. So basically, we will be using the Keras API of TensorFlow. So, but basically, TensorFlow 2 has the Keras API built in. Okay. Now we will also touch upon the other machine learning frameworks such as Spark. If time permits, we might give you an overview, or we will see if we can invite you to other Spark session. Now, machine learning frameworks. There are other machine learning frameworks other than these deep learning frameworks, such as scikit-learn, NumPy, and Pandas. NumPy is basically a big array which lets you manipulate numbers. Pandas is a big table, just like a database table, which lets you manipulate a database table, right? And scikit-learn has most of the algorithms already, except for the neural network. Scikit-learn is very rich library, really handy, and almost every algorithm of machine learning is available as part of scikit-learn. Just that the deep neural network one is not that handy, or is not available in the scikit-learn. Okay, so we will be, as part of this course, we will be learning Pandas, NumPy, scikit-learn, and TensorFlow to the Keras API. Okay. There was one thing that I wanted to discuss, and I had planned for that part. Okay, just give me a moment. I'll have to. Okay, I have to pause the video for a moment and then. Okay. Just give me a moment. I have paused my video purposefully, and I want to walk you through what is computer vision and so on. Okay? Just give me a moment. I'm trying to. All right, I'm just starting this. Uh, I'm just picking few things so that I can show you some really, really important things. All right, so coming back to it, and we are just unsharing my screen. Okay, so one thing I wanted to discuss further, somehow these slides got deleted from that. All right, I hope everyone is able to see my screen. All right, let's move ahead. Okay, here we go. Now, we were talking about the various libraries. We will be using pandas, numpy, scikit-learn, and we will actually start with Python. Python is self-paced. Pandas and NumPy is also self-paced for you. So while you have some time to study, I would say that log into CloudX Lab, go to my courses. You will see these self-paced courses for yourself, and then finish those self-paced courses, self-paced chapters, and from the second session onwards, we are going to use scikit-learn right away. Okay, and after the machine learning, core machine learning is over, we're going to talk about the TensorFlow. All right. Now, other use case you will see is the computer vision. Deep learning is powering the computer vision, and it has been able to do it so well that the other classical ways of doing the computer vision is no longer mainstream. Deep learning has basically the techniques which are based on deep learning are way more powerful than the classic approaches, right? So computer vision is essentially the ability to see, ability to predict based on what we see, right? When we take photos, when we take selfies, when we take photos, when we are using drones, when we are taking selfies, when we are doing self-driving and so on, computer vision is everywhere. Now, this is something very important. This is something that I want to talk about here. That computer vision is essentially used in recognizing the image, doing the image processing. And this part, I've been busy with a couple of projects in material sciences, and we are applying computer vision in material strength and other characteristics and so on. So there are many examples of computer vision being applied in all branches of sciences. So computer vision is being able to see. And you will learn in one of the chapters called CNN, Convolution Neural Network. Those are the specialized neural network designed for doing the visual processing, doing the computer vision processing. So computer vision is essentially using the computers to do the vision related work. And computer vision is basically dominated by machine learning algorithms. The classic algorithms are rarely used. The algorithms which wrote by people are not used in mainstream. Instead, those algorithms or those models that machines came up with, they are way more real, way better. Okay, so this computer vision has application in every branch of human sciences, be it physics, for optics, image processing, speech and natural language processing, robotics, normal machine learning, information retrieval, system architectures, graphs and theories, and so on. And computer vision is mostly overtaken by this. All right, so I hope my voice is clear. All right, now here is a very interesting phenomena I'm going to talk about. There's one question that I want to answer. There's a question from Nikhil. How is AWS ML different than all of this? No, it's not different. AWS ML is essentially taking these algorithms and running on the cloud of AWS. It's the same algorithms. All the algorithms Amazon or Google are providing you, they're all open and public. All of those. I haven't seen a proprietary algorithm so far which is not yet public. Okay, and therefore whether you use AWS, Google or Microsoft clouds or whichever API you use, the machine learning understanding is common. Machine learning understanding is common. Whether you are using Python, whether you are using C++, whether you are using Java, the machine learning or deep learning understanding of the subject is common. Even though we will be using Python in this, you will find that using other languages is similar. There's no difference at all. The ideas remain the same. All right, wonderful set of questions. Great question. And even, yeah, Spark machine learning is also the same thing, right? The ideas are identical. Whatever we are going to discuss in this course is widely applicable. Though we have kept it in TensorFlow and scikit-learn because the entire learning has to be real, more experience oriented, so that as you do more hands-on, you will be able to learn by the way of building your mental model rather than memorizing what we are saying, right? Therefore, today's session is probably the most theoretical session out of all of them, the remaining sessions, because today's session is something that is around ideas and concepts. Okay, we are going, and this is an open session. So this is more theoretical. As we go ahead, it is going to be more and more practical. So I'm going to talk a little bit about something called ImageNet. This is basically, I'm touching upon the machine learning or deep learning in computer vision, okay, in being able to recognize. So there is this international challenge. It's basically a competition where all the big B's of the world, Googles and Microsofts and all kinds of researchers, come and compete. What they compete on is, you given a photo, you have to identify whether it's a leopard, container ship, motor scooter, mite, or any of those 1,000 objects. So given an image, you have to tell what are the things inside that photo, right? Like CAPTCHA, you must have seen, right? So just like CAPTCHA is for people, this is for machines. So machine is supposed to, given a photo, machine is supposed to predict what is there in the photo. So ImageNet challenge is an international challenge whereby you have to train your model on 1.5 million images which are already tagged as one of these, one or more of these objects, and given a photo you have to predict what object is there in the photo, right? This is ImageNet challenge. Now in this ImageNet challenge there have been a lot of learning, lot of competition, and over years this is what we have. So this is the error rate we are talking about. The error rate in 2010 was 28%. Humans' error rate is 5, while the error rate in as you can see that initially the error rate was high in 2010. As we went ahead in this competition, the winner of the competition in 2011 was somebody whose program was giving this much error. And in 2014, the error rate was dropped to 6.7. Now this was the remarkable event in the history of deep learning. This was the remarkable point. In 2015, the computer vision or neural networks, the deep learning, overtook humans. Human makes a mistake of 5.1% on those many objects. It's not exactly 5.1. There is I could go into more details of that one. We'll discuss it in later point of time. So human makes a mistake of 5, while in 2015 the computer started making only 3.6. Now as of 2017 the error rate has been dropped to 2.3. Two point three is something is amazing. It's half error than the human, right? So you can see it's not we can't say that, oh, it's just 2 points smaller than 5. It's twice better. So what you see here is that this point is the place, this is the point where the computer would solve CAPTCHA better than human. So CAPTCHA is no longer a valid way of figuring out whether something is a human or not. Okay? Because the computer is making less errors than the people. And this is amazing. The error has not gone up, error has reduced. From 3.6 it went down to 3, then 2.3. Okay, so the error has gone down. This one is human. So you can see that this is a very remarkable thing that happened. All right. So I'm going to take more questions here, and this all what you see here is basically because of deep learning, deep neural network. We will study this in more details in CNN chapter, and one more chapter is there called GAN. All right, let me take questions now. So about the batch that is launched today, it is over full. Even though first session is on 6th June, it is basically full. We can't take any more enrollments into this May 31 batch, and June 28 is open. The applications are free. You can just go to the website, apply, give a test, and the team will review, and IIT Roorkee will review your profile and will approve or deny based on your performance as well as profile. So okay, so you can take a look at the course there. Okay, now okay, so this is this is the okay, so basically we have a limited seats, and this one is also has started filling fast. So yeah, I would say that even if you are not that inclined right now, but at least, or you want to decide later, you want to decide later, even then I would say that apply right away. You can just go to the website and apply now. Okay, and yeah, the timing is right, so the timing is same as the current one, and the price is that way. All right, now I would like to go for your questions if you have, and feel free to ask your questions. Okay, what is PST? PST is Pacific time. Okay, and here it is IST. IST is Indian time. Okay, so total duration of the course is 45 hours, but I'm very sure that it will extend. While the the class will be from 8 p.m. to 11 p.m. and 7:30 a.m. to 10:30 a.m. in PST. It's the same time. Okay, it just converted into PST, different time zone. And okay, it's a 45 hours live classes, and I understand that it is costly for many. In case you are looking for low cost ones, you can go with the self-paced classes that are listed at CloudX Lab, and probably that would help you in achieving the deep learning understanding. This course is strictly from IIT Roorkee, and given the these prices and everything is decided by IIT Roorkee. The professors from IIT Roorkee, as well as the instructors chosen from industry, they will be driving the course. And CloudX Lab is a platform where the courses will be available, LMS is available, and so on. In case you have not tried CloudX Lab, do try it out. At least the free tutorials, the free courses like Python and Linux you must try, because you will get to know that what exactly is automatic hands-on assessment. So we are trying to gamify the way you do exercise, and that's the main motto of CloudX Lab. All right. Good. A question from Rohit is, one of my earlier question was, isn't unsupervised machine learning an extreme form of supervised machine learning where you provide a large cluster and some guidance to form the groups? Good question, Rohit. The thing is that we don't, in case of unsupervised learning, we don't provide that guidance. On what basis are we forming the group? We are only providing the features or characteristics of the example dataset. We are only saying that, hey, here is an album, can you group the photos into say 3 groups or any number of groups you want. We are not telling what will be there in the individual group, right? If the question was like this, please group the photos year wise, and we have already told that which photo belongs to which year, or let me just put it this way, let's group the photos which are of let's say our family, or let's group the photos which belong to a festival and not a festival, trip photos and a festival photos. Let's say those photos you have to do the grouping. In this case, you will have to provide this data that this photo means festival, this photo means party, this photo means festival, this photo means party. You have to provide this data. In that case, this problem statement is supervised learning, because the task is to group the photos, or classify a photo into a party or festival based on the pixel values of each photo, correct? That's supervised. But unsupervised is, here are the photos, can you organize them into some groups? I don't know on what basis, just figure out, look at the data on whatever basis you feel like, or whatever way the label of the group, it's up to you, right? That's unsupervised. Good question, good question. I hope I was able to answer your question. All right, thank you, Ankur. I'm happy that you liked the webinar. The session is recorded, so don't worry. And also come over to our discussion forum. It's a very active discussion forum. Lots of people answer your questions. And here, this is where you will get lots of questions. Question from Kunal is, will be using Spark ML Lib? No, we will not be using Spark ML Lib in this. We'll be using TensorFlow mostly. Okay. But on CloudX Lab, the Spark ML Lib is available. You can try out. It's actually Spark ML. Yeah. Okay. Earlier it was called ML Lib, but then they changed it. All right. So wonderful set of questions, and a question from Krishna is, what is the scholarship policy for the course? So whenever you get the scholarship, your amount is refunded. So the way we did this time is that top 10 candidates got 10% off, 10% refunded, and the next 5 candidates got 5% refunded. Okay. These are all weekend courses, and this will be on Saturday and Sunday. Okay. You will get a certificate for the course, but for not for this particular webinar alone, because this webinar is for your knowledge and for the introduction. It's not really possible. Even if it is possible, we won't be able to give the IIT Roorkee certificate. Okay. Thank you there. I'm really happy to see see your positive feedback. A question from Ankur is it possible for AI to face the third winter? It should be. Okay. I don't think that AI is going to enter into the third winter. It has like bad days in past. Bad days in the sense that in the beginning people thought that they have come up with the AI, but it did not really work out because of the results being very vague. But now it's practical, everybody is using it, has already replaced things, replaced the interesting. A question from Rajiv is that any job opportunities after the course? Yes, we will be actively, and we are already actively working with various recruiters, and we're ensuring that any candidate who's enrolling into this course will get a fair chance of applying, fair chance of interviews. We are trying hard to get that in place. There is something that is already there. We have a couple of recruiters already there. We keep sending emails. Also, one of the things that with CloudX Lab is that we prefer the candidates from our own batches. Of course, there will be a separate interview, there will be a separate test, but we prefer the candidates from our own platform, because we are very confident that the people who actually finish the course are the people who are passionate, who are good learners. Okay. All right. Very good set of questions. Thank you so much. Have a good day. I hope this session was useful to you, and it's good that we finished on time. Just that in the midway, we kind of, those couple of slides were missing, so we took extra 1 minute. All right, wonderful set of questions and wonderful audience. I really enjoyed your questions. I hope this session was useful to you. Stay connected, and those who have enrolled for the course, see you on the coming Saturday. On the coming Saturday, the content of the event is going to be same as today, just that only the people who are enrolled in the course will be invited to that. And from the next Sunday, as in coming Sunday, we will be continuing from the second session onwards, like end-to-end chapter. All right, stay connected with us. If you have technical questions, come over to discuss.cloudxlab.com. If you have any questions related to the payment, any questions related to other your account problems or so on, do drop us at reach us at CloudX Lab. All right, bye bye. Have a good day. Thank you.